Question 5a. Use the principle of mathematical induction to show that 2 times 1 factorial plus 5 times 2 factorial plus 10 times 3 factorial plus plus n squared plus 1 times n factorial equals n times n plus 1 factorial for all positive integers n. The first step is to show the statement is true for some value of n, and the smallest value of n that we can test in this case is n equals 1. From the left-hand side of the statement, we have 2 times 1 factorial, which equals 2, and the right-hand side of the statement is equal to 1 times 1 plus 1 factorial, which also equals 2. Left-hand side equals right-hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k for integer values of k greater than or equal to 1. That is, 2 times 1 factorial plus 5 times 2 factorial plus 10 times 3 factorial plus plus k squared plus 1 times k factorial equals k times k plus 1 factorial. Next, we show the statement is true for n equals k plus 1. So from the left-hand side of the assumption, we have 2 times 1 factorial plus 5 times 2 factorial plus 10 times 3 factorial plus plus k squared plus 1 times k factorial plus the next term along, which is k plus 1 squared plus 1 in brackets times k plus 1 factorial. And this statement can be simplified by using the assumption that's replacing these terms with the right-hand side of the assumption, which is k times k plus 1 factorial. So this can be simplified to k times k plus 1 factorial plus k plus 1 squared plus 1 in brackets times k plus 1 factorial. I've just made a note here from the assumption. And we can factorize out k plus 1 factorial from both of these terms. So we have a k plus 1 factorial here and a k plus 1 factorial here. So factorizing this expression, we have k plus 1 factorial times k plus k squared plus 2k plus 1 plus 1 factorial. So that's also by expanding this bracket here. Next, we collect the like terms. So that equals k plus 1 factorial times k squared plus 3k plus 2 factorial. Now we have a non-monic quadratic here, which can be factorized. This equals k plus 1 factorial times k plus 1 in brackets times k plus 2 in brackets. Now k plus 1 factorial times k plus 2 is equal to k plus 2 factorial. So we could write this as k plus 2 factorial times k plus 1. So just swapping the terms of the product around. So that equals k plus 1 times k plus 2 factorial, but n equals k plus 1. So rewriting this line here in terms of n, that equals n times n plus 1 factorial, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all positive integers n.